Okay, so in the previous tutorial we have fixed some of the bugs, and as the latest feature we have added orientation warping, right? So the orientation warping means basically we keep playing the existing animation, but whenever we move to a diagonal direction, instead of playing a different animation or sliding through ground, we simply rotate the corresponding root bones or spine bones to that specific direction. Therefore, the animation will be much more realistic, right? So actually, we have added that orientation warping capabilities for both starting, cycle, stop. I think not stop, but start, cycle, and pivot states, right? So now we have that capability. So when it comes to the warping technologies, we have another technique called stride warping, right? So the stride warping, in the sense, based on the speed, we make the length of the foot placement dynamically, right? Which means that basically, like, let's say whenever we starting our animations, actually we are starting with zero velocity and we are moving towards for a specific velocity threshold, like let's say 400. So this will happen when the acceleration involves, yeah, like continuously the velocity is increased. But currently what you see in a start animation is like the footsteps are not quite responsible or quite sensible that velocity change, right, or acceleration. It simply plays the exact amount of foot placements for each iteration, right? But actually what should happen is like whenever the character remain at the idle state and he's jumping to a cycle state, initially this foot step distance or foot length should be dynamically adjust, and it can keep increase. So that's what stride warping does, and let's see how we can add those features, right? Okay, so we can actually start from the our animation graph. So I have opened the BP locomotion. Inside locomotion, and here we have the start state, and currently we have added this orientation warp, right? So in case if you forget where did we get this node, basically the plugin section, here we have a plugin called animation warping. So this animation warping actually provide these orientation warping capabilities, similar to the stride warping, right? So let's add stride warping node here. Yeah, here, and we have these nodes, right? So for the alpha, we need a pin that has been exposed, so we can manipulate it as a variable, which is fine. But we need to manipulate the locomotion speed as well. Therefore, I can change this evaluation mode to graph, so it will expose this pin, right? So in the manual mode, actually it gives us these two options. We can either manipulate the stride direction and the stride scale, but if we use the graph mode, those values will be automatically resolved. All we have to provide is locomotion speed, right? This locomotion speed can be considered as displacement speed, which means like each frame how much speed displacement we have, right? And for this alpha, we can call it as stride warping alpha. So we can increase this alpha continuously, and the foot placement will be adjusted dynamically, right? Okay, so if I yeah, I can't compile it now because I have to adjust the bone mapping or bone hierarchy at the foot definitions, right? So currently you can see the foot definitions are quite empty. So this node doesn't know what are the bonds that it should manipulate, right? So since this stride warping is involved with foot placement manipulations, obviously the bonds should related to foot. So the pelvis bone should be pelvis, and the IK foot root bone should be IK foot root, and we need to add set of foot definitions, right? So in our mannequin character, we have left foot bones and right foot bones. So let's add both of these mappings in this section, right? So at the first index, I will add IK foot R and foot R, and finally thigh R, right? Similarly, let's add IK foot L, foot L, and thigh L, right? And we can keep the configurations as it is, but I believe we can clamp our foot placement interpolation mappings, interpolation ranges, right? Because we don't need our foot displacement is in a higher, so it will be quite unrealistic. Plus we don't need it to be exponentially minimum as well, right? So let's clamp the result and interp results as well. So clamp minimum should be 0 and 1, that would be fine. And let's keep the interp speed increasing and decreasing as it is, right? So let's see other stuff. The flow normal direction, that would be fine, and gravity direction, world space, again that would be fine. And the pelvis IK foot solver, yes, we can keep the keep these default values as it is, right? Yeah, so only a change that we have been done was this one, right? The stride scalar modifiers, we have enabled these clamping and interpolation results, right? If I compile it now the error will be gone, and I can give it a play test. Now you can see like we have this weird foot IK, right? What could be the issue? Yeah, this is the first issue because in the left IK foot bone I have been added it as IK hand it, right? That's the issue. So let's make it as IK foot L, compile, save, and play it again. So now that error has been gone, right? So now you can see there is no stride warping applied because I have set the alpha as 1. But if I make it as 0 and play it again, you can see small change is there, but it seems quite unnoticeable. Maybe let's increase the locomotion speed and play it again. Yep, it is pretty much unnoticeable with the manual inputs. But yeah, instead of adding manual inputs, let's take the displacement speed calculator and we'll see how it works. Right. So let me quickly look at my documentation. And okay, so we have a thread safe function called update location data, right? So here we are simply capturing the world location only for now, right? Yeah, so let's calculate the displacement speed. But in order to calculate the displacement speed, actually we have to capture displacement at the previous frame, right? Therefore, I will use this property access pin and subtract world location. So this is the previous frame captured world location. So if I use it here, it will be used to calculate the previous frame world location value. And then let's get the vector length x and y, and I can promote this to a variable and I'll name it as displacement since last update. And let's move it to the location data category, and let's this be okay. Plug it here. File save. Right. So I'll select this no debug object selected, so it will disable that execution pin rendering. Right. This is just a visualization to debug like how your execution of each node happens. So since you are developing it now, we can simply disable the debug. Right. Okay, so we have captured the last frame displacement, and then we can use this displacement plus this delta time and let's safe divide it, right? And finally it can be promoted as displacement speed. Okay, right? And we have to determine whether this is the first frame or not, because at the first frame our displacement speed and the displacement since last update should be 0, right? Basically it's like a initialization. So we have this set first update variable. Let's take it here, and if this is the first update, which means the very first frame rendering, then we simply initialize displacement since last update as 0 and displacement speed as 0. And I'll move it to the location data as well. Compile. Save. Okay. Now we can go back to the start state, and there, instead of hard coding this locomotion speed, let's plug this displacement speed. Compile, save, and play it again. Okay, so let's increase the alpha a little bit. Okay. Right. So I debug it further. I actually this stride warping is not playing because currently this displacement speed is capturing properly, right? But in order to test this out, basically, we have to keep the alpha as 1 because then the stride warping will be applied entirely. But for instance, let's make this locomotion speed as 0 and compile, save, play it again. Right, now we can see small foot placement is there for the start state, right? But it's almost unnoticeable for this start state because the animation is bit smaller. right? So just for testing, let's add this stride warping node for the cycle state as well, and we'll see how it works in action. But ideally we have to add this stride warping node for both start and cycle state. Therefore let's go to the cycle, and I'll make some space here, copy it, and add these nodes, right? So the bone mappings and other configurations as it is, because we have been copied the node entirely, right? So I compile and save and play it again, and just see what will happen. It's entered the cycle state, right? So you can see the foot placement is now very small, right? Because we have passed the alpha as 1, so the stride warping is applying entirely, and the locomotion speed as 0, right? So when it enters to the cycle state, now our animation graph think we are moving in a very slow speed, right? Because the locomotion speed is provided as 0. But let's increase it for like 100, and let's play it again. Now you can see at the cycle state, now it has sort of a bigger foot placement. Let's see if I increase up until the 400 and play it again. Now you can see we have a higher foot displacement, right? And let's say we make it as 1000. Now we have very large foot placement happening, but it has been clamped, right? It doesn't modify the foot displacement like in some unrealistic range, because this clamping and interpolation happens, right? Okay, so anyway, now this stride warping works, and we just have to apply that displacement speed here. But I'll come back to the cycle state later on. First let's finish the start state, and we'll see how it works, right? So I just reconnect this pin, but ideally later on we have to do that stride warping here as well. So at the start state, now let's plug the locomotion speed, right? And then instead of applying the alpha like 1, we have to dynamically resolve this alpha value as well, right? So we can calculate it at where? Yeah, so at the start in the sequence evaluator on become relevant, this is the first function that has been called. So first let's go there, and soon after we set the explicit time, let's initialize a new variable called stride warping start alpha, and initialize it as 0. So stride warping start alpha, which is a float, and I'll assign it to a new category called maybe stride warping, and let's take this variable to here, mark it as 0, pass it to here. Okay, and then as the second function, the sequence evaluator on update function call. So each frame actually this function is getting triggered. So let's go there, and let's calculate this stride warping start alpha here. Okay, so in order to calculate the stride warping start alpha, we need to determine what is the explicit time for this specific frame. So let's get this node sequence evaluator and call get accumulated time, and I'll promote it to a local variable called explicit time. Right, and then let's get the explicit time and subtract it based on the stride warping. No, actually not the stride warping. We need some pre-configured values as well, because sometimes we need to add some offset to these values. So let's create a new variable called stride warping blend in start offset. So these are configurable values, therefore I will assign it to a new category called, actually we have this category which is settings. So I'll push it to here, and as the default value I'll make it as 0.15. and now let's take that variable here. So I'm subtracting that specific offset, and let's map range values. The range should be 1, and the maximum range I'll promote it to a new variable called stride warping blend in duration scaled, and pass it to the settings category. And as the default value, let's make it as 0.2. So actually you can play with these default value settings variables default values, but I think these two values would be nice to have, because the Unreal Engine Lyra sample project also has these two variables initialized as these two values, right? But based on the animation sequences that you are using at the data table, maybe these values need to be tweaked. Okay, and as the out range, the minimum should be minimum should be 0, and the maximum should be 1. Then finally, let's push it to here. Let's plug this return value to here. And I think this category name is wrong, so I'll quickly update it. Yeah, stride warping. Not the stride wrapping actually. Stride warping. Okay. Now we have calculated that stride warping. So let's go back to the start state, and here at the alpha, now we can plug this variable to here, right? So the stride warping will be resolved dynamically for the start state. So let's play this again, but it almost unnoticeable because the animation sequence playtime is very low, right? But as I demo before, as I did at the demo, at the cycle state, it will be much more convenient, right? So now let's implement the stride warping for the cycle state. And I can copy this displacement speed and stride warping node as it is, and go to the cycle state. At here, let's paste it and attach the pins properly. And here we have to resolve the alpha for the cycle state as well. So how to calculate the stride warping cycle alpha? Yeah, here we doesn't have some initialization on become relevant function. Here we only have this on update function. So let's go there, and at here let's create a new variable called stride warping cycle alpha, and plug it to here. Right, and then let's get this stride warping alpha, plot interp to maybe the target as 1, right? And for the delta time, let's get the context, and through that we can get the delta time and attach it to the delta time. And as the interp speed, I'll give it a value like 10, right? And plug it to here. Actually, this target value also can be customizable later on, because I'm thinking about adding some wall detection heuristics as well, which means like if the character encounter a wall, then these sort of cycle alpha increase float interpolations should be increased for a lower target value. Therefore, we can maybe mark it as provide it as 0.5, but it should be dynamically resolved whenever we found a specific wall and stuff, things like that. So such wall detection heuristic we can add later on as for the improvements, but for now let's keep it as 1, right? Maybe I'll add a to do here so we won't miss that feature in future. Maybe let's say add wall detection heuristics. Okay, right, now we calculated this stride warping alpha, cycle alpha actually, and let's go to here and I'll attach that variable to alpha. Compile, save and play. Okay, now you can see that stride warping has been added, right? Right, so let's test maybe walk. And now here you can see the walk animation is very realistic, right? No foot sliding, no unnecessary displacement. The foot is placing exactly on the ground for that is that matches with that exact speed, right? And our animation is very smooth and very realistic and very accurate as well, right? Let's test the crouch as well, right? So here you can see for the crouch the speed is bit higher than the walk speed, so the foot displacement will be bit higher as well. Okay, right, so we have added the stride warping for the start state and the cycle state, and finally we can add it to the pivot states, right? So let's go to the pivot state machine, pivot A, right? So I'll make a space here and paste those nodes, attach the pins, and here we need to calculate the stride warping pivot alpha like we did similar to the start and cycle states, right? So here we have the one become relevant function. Let's go there, and soon after we set this set explicit time, let's create a new variable called stride warping pivot alpha and let's initialize it as 0 at the very first frame call. And then let's go to the one update pivot anim layer function, right? So there yeah, what we can do. Right, so here we have calculated the velocity. Yeah, so after that, yeah, maybe I'll add a sequence here, because later on we have to add some of the new features as well. Therefore, it's better to organize the code in the sequence node man. Right, so it will initialize some of the variables in the first sequence, and after that we can set this stride warping pivot alpha, right? So we have to calculate the explicit time as well. So I'll go to the very first execution pins, and maybe we can use this one. I'll get the accumulated time, promote it to a local variable called explicit time, and attach the execution pins and go back here. Right. Yep. So let's get the explicit time, and I need to determine time at pivot stop as well. Do we have the time at pivot stop? Time at, no, we don't have that variable. Right, so let's quickly make another variable called time at pivot stop. I'll assign it to a category called pivots, and let's go back to the setup pivot anim layer, and here I'll initialize this time at pivot stop like this, right? And add the on update before this calculation. Let's set this with the explicit time. Okay, right. But actually this set should happen if the acceleration is opposite to the velocity direction. Only if the acceleration and velocity is opposite directions. So in order to calculate that, actually we can get the local velocity 2D and local acceleration 2D, and let's do a dot product, and this dot product is negative, then we have the opposite direction for the velocity and acceleration, right? So I'll comment it as acceleration, let's say is acceleration opposed to velocity, right? So only if it is opposed, then this set happens. If not, we can set our stride warping state alpha like this. Right, so let's get the explicit time, and let's subtract time at pivot stop. Plus we need some pre-configured settings as well, like we did before. So I'll add a new pin, promote it to a variable called stride warping blend. No, actually we don't need to add a new variable because we already have that variable, right? Or maybe I'll remove this one, this one. Let's use this existing variable. stride warping, blend in, start, offset. Right? Okay, then let's map range clamped, in value be 0, in range p value should be blend in duration scaled like we did in the start turning. And then range A should be 0 and range B should be 1. Plug it to here. Okay. So now we have the stride warping calculation, alpha calculation for pivot. So let's compile, go back to the pivot state, and let's plug that stride warping alpha. Okay. So maybe I'll explain what we have been done again, because it's a bit long for the pivot. So first we initialize the stride warping pivot alpha and time at pivot stop, and then at the update pivot enable layer function, we first check whether the acceleration and velocity is pointed to opposite directions. So if it is pointed to opposite direction, then we recalculate the time at pivot stop based on the explicit time. And if it is not opposite, which means the acceleration and velocity is pointing to a same direction, then we simply increase the stride warping alpha based on these specific values and pre-configured settings, right? And then that stride warping alpha can attach to this stride warping alpha pin, and based on the displacement speed, it will keep increase the alpha for each frame dynamically, right? So let's copy these 3 nodes and go to the pivot state machine, pivot B, and here let's plug the same pins, same nodes, right? Compile, save all, let's play. Okay, now you can see even at the pivot, now there is no foot displacement or foot slide, not unrealistic foot displacement or foot sliding, right? You can see at the pivotal change, the stride warping has been applied, right? So this is for left and right. Great. So animations are pretty much accurate and pretty much smooth. Okay, so that's how actually we are going to use warping techniques. So actually I think considering the orientation warping and stride warping would be pretty much enough in this project, but if you look at the plugin, it will provide slope warping as well. So if you want, you can apply this slope warping to your locomotion system, but later on actually we are going to use the Unreal specific IK rig. Therefore it will basically like applying the slope warping sort of like a behavior for us, right? But it may not be exact same slope warping that is mentioned here, but in our scenario that would be pretty much enough, right? So those IK resolver and IK rig attachment stuff I will discuss in the next upcoming tutorials, but for now I just want to mention how we apply the stride warping to our system. Okay, so I think that's it for this tutorial, and I'll see you in the next one. Thank you.